All right, for the first part of this question, we're going to evaluate j of negative 1 given this, what j of x is equal to. So let's go ahead and get started on doing that. So j of negative 1 is going to equal 2 times negative 1 to the power of 4 minus negative 1 cubed minus 35 negative 1 squared plus 16 times negative 1 plus 48. Wow, okay, so you can see basically what I did is I just replaced all the x's with negative 1. Just for time's sake, I'm going to solve this really quickly. You should get that j of negative 1 is equal to 0. So the question, explain what your answer tells you about x plus 1 as a factor. Well, this confirms that x plus 1 is a factor of j of x. Now we can also confirm this by taking the original polynomial and dividing it by x plus 1. And we can do that fairly quickly using the synthetic division method. So we're going to set this up. Since we're dividing by x plus 1, we're going to write negative 1 on the side here. And then our coefficients are 2, negative 1, negative 35, 16, and 48. So to start off, we carry the 2 down, and then multiply negative 1 times 2 is negative 2. Adding those, we get negative 3. Multiplying negative 1 times negative 3 is positive 3. Adding negative 35 and 3 gets us negative 32. Multiplying negative 32 by negative 1 gets us positive 32. Adding those gets us 48. And 48 times negative 1 is negative 48. Adding those, we get 0, which is our remainder. So that also confirms that x plus 1 is indeed a factor. Now, for the last part of the question, we're asked to algebraically find the remaining zeros. Now, there's another reason why I did this synthetic division here, is because now we're basically factoring out x plus 1, and what's remaining is this polynomial here, which written out properly would be 2x cubed minus 3x squared minus 32x plus 48. And we're going to set it to be equal to 0 and factor. So we're going to look at this piecewise. I'm going to split it into 2 terms and 2 terms and factor each of these individually. So looking at 2x cubed minus 3x squared, we can factor out a common factor of x squared. And we'll be left with 2x minus 3. And then here we can factor out a common factor of 16. And in brackets, we'll have 2x minus 3. Be very careful here. Notice that it's not 2x plus 3 because we're basically factoring out a negative. Negative makes this positive 48. Anyway, at this point, you'll notice that with these two terms, they both share a common factor of 2x minus 3. So if we factor out 2x minus 3, we'd be left with x squared minus 16. And we can actually factor this a little bit further, and that's because x squared minus 16 is an example of difference of squares. So this would be factored to become x minus 4 times x plus 4. All right. Now what we're going to do is we're going to set all 3 of these sets of brackets equal to 0 and solve for x. When you do that, you will figure out that x is equal to 3 over 2, x is equal to positive 4, and x is equal to negative 4. So those are the other remaining zeros of j of x. All right, hope that was helpful, and that's all for this video. Thanks for visiting JD's Preparation.